Hi, folks. My name is Rob Meyer. I run outbound product management at GridGain Systems. I'm not the speaker, however. I'm just your commentator. So I'd like to introduce Dennis Magda. And I don't know, I'm thinking most of you know Dennis. He runs inbound product management. He is also the Ignite PMC chair. And Dennis is going to talk to us today about what's new in the latest release of Apache Ignite 2.7. Before we start, I do want to make sure everything's working with the audio and video. So please raise your hand using the hand icon located in the GoToMeeting webinar. You should see a little orangish hand up in the upper right. Raise that, let us know that you can hear us and that everything's working well. If you can't, we will try to help you. There we go. I see some hands going up. Perfect. We will try to help you along the way. You can also comment in the chat window that you should also see in the lower right. I'll be answering questions throughout the webinar, but I always save the hardest ones for Dennis because that's what I like to do to Dennis. So for those of you who don't know GridGain, we are the company that originally contributed code to the Apache Ignite project. We continue to be the leading contributor, although there are plenty of other great contributors out there. And we provide a commercially supported version of Ignite that folks tend to use in business critical deployments. So with that said, I'd like to turn it over to one of the Ignite experts, Dennis Magda. Dennis, take it away.
Hello, Rob. Hello, everyone. Thanks for coming to this presentation. And so basically today, I'll be honored to present all of the new improvements and features which became available in the latest Ignite version, which is 2.7. Basically, once I switch to the next slide, we're not going to review every individual improvement, right? The list of improvements is pretty exhaustive. But today I'd like us to focus on the four most prominent contributions to Ignite. First of all, we'll look how studying Ignite 2.7, Ignite began supporting deep learning workloads. We did this by integrating with TensorFlow framework. At the same time, we expanded a set of the languages which you can now use to communicate to your Ignite clusters. That happened thanks to some of the changes at the protocol level, which now allow us to create and support any possible language as soon as possible, as quick as possible, sorry. And next, transparent data encryption. You can store the data in Ignite, you can get scalability and performance improvements, but at the same time, some of the data is sensitive, some of the data is personal. And with the transparent data encryption, you can decide which data you'd like to encrypt, so that if anything happens to your deployment, let's say that someone hacked it, someone got access to it, the data will not be decrypted. So nobody will use your data inappropriately. Transactional SQL, again, even though this feature is still in beta, we'll see what's already supported and how you can try it and what to expect next. And for sure, we'll have enough time for Q&A sessions. All right, let's start with the deep learning in scale, and specifically focusing on the TensorFlow integration. But before, I'd like us to spend a minute or so and remind ourselves what Apache Ignite and GridGain is, so that you know why some of the improvements and some of the contributions ended up in the product. Ignite, as you know, is a distributed memory-centric storage. And when we're talking about memory-centric storage, it consists of two primary layers. The first one is the memory component in memory data store, which can be used as your primary layer. And also you can persist data to disk. And you have many persistence options. You can persist to Ignite native persistence, which is well integrated with the overall memory architecture and supports all of the APIs possible. Or you can use our in-memory data storage, together with your existing database, such as Oracle or MySQL or Postgres, or it can be mainframe deployment, or it can be Cassandra. The idea there is that GridGain or Ignite caches all the data from your underlying database, and that's how you achieve speed and scale. On top of the storage, we have a variety of APIs, which are used for a vast amount of use cases. We have compute grid, it's our MapReduce. We have transactions, SQL, key value, machine learning, and deep learning, studying Ignite 2.7. Speaking of the improvements which we mentioned on the agenda slide, you see here is on this slide you see two bricks. The first one is transaction, the second is SQL. Before Ignite 2.7, whenever we talked about transactions, we assumed key value APIs. So yes, Ignite transactions are used in production at banks and other financial institutions. People and companies used Ignite transactions to transfer money and to ensure our bank accounts stay in consistent state. But there was a limitation. It was impossible to use SQL for distributed transactions. And that's, for instance, what we are going to explore, what was added in 2.7. Machine learning, yes, we with Ignite 2.7 released much more algorithms related to machine learning. They were rolled out. Now this component is in GA state. It's no longer the beta, so go ahead and try it. And also integrated with TensorFlow, so some more additions. And all of those blue columns, which you see to the left, to the right, are something that you can get available if you use GridGain, right? As Rob said, GridGain initially donated Ignite to Apache Software Foundation, but at the same time, we provide enterprise-level features on top of open source functionality, such as management and monitoring, advanced security, full cluster snapshots and backups, point-in-time recovery, rolling upgrade, etc., etc. All right. Let's go to the machine learning and deep learning conversation. We call it continuous learning framework, and let me explain you why. So right now, if we are dealing with machine learning tasks, usually the workflow is pretty straightforward and established, and it's represented to the left of the slide. You can have an application, your business application, your OLTP application that is handling your business use case. You can get it. That can be a commerce store which receives different orders from your customers. Also, the application tracks customer behavior so that everything can be adapted and customized based on our preferences, and all of the data goes initially and stored in your relational storage. Then also periodically you ETL data from your operational storage to your Hadoop, or not even to Hadoop, but to your data warehouse. And that data warehouse is your data lake, which can be used by machine learning or deep learning engine to train different models, which can be promising, which can optimize your business, which can bring more value to your customers. But usually those models being trained on the already stale data, the data that is ETL periodically from your database. And then, like, once you train your model on that stale data, you will go ahead and redeploy it in your business application. And for some of the applications, and for most, I would say even nowadays, for most of the applications and use cases, it's totally fine to follow this workflow. But now you see that we are living in the age of real-time processing, real-time queries, real-time streaming, real-time everything. And it's inevitable that many machine learning and deep learning routines also have to be able to act or process or be updated in real time as well. And that was the primary idea which we kept in mind when we initiated the development of machine and deep learning component of Ignite. So with Ignite, you can see Ignite as your primary storage. which is used for your operational workloads, but at the same time, for instance, with the usage of Ignite native persistence, you can store historical data in the same cluster. And then whenever you're getting any updates from your business and customer-facing applications, you can retrain, you can update your machine learning models iteratively without having any ETL process in place. So that's the idea, right? And we hope that this idea will be applied and incorporated and will be used going forward. And from the technology perspective, that's what you can already expect from Ignite. That's how you can already use Ignite. And that's why continuous learning. Continuous learning implies that your historical data, your operational data can live in the same data storage, in the same platform. And depending on your needs, depending on your business needs, you can skip your ETL process. You can update your machine learning models in real time, as long as new data is coming, and you can redeploy them in production. That's the idea, which will be tested and hopefully deployed and used by many production deployments. So what's next? If to look into the machine learning and continuous learning framework capabilities of Ignite and GridGain, here they are. So again, the storage is the same. You can use in-memory data store, and you will be using it. You will decide how much data you'd like to cache in RAM. And at the same time, speaking of persistence, and especially when it comes to the historical data, to terabytes, petabytes of data, you don't need to store all the data in RAM. You will store 100% of the data on disk in Ignite persistence, and then you can cache, let's say, your hot data, your operational data. And on top of the data, you already know that Ignite supplies you key value APIs, compute and service grid, etc. But as for the machine learning algorithms such as linear regression or decision trees, clustering, etc., they are available out of the box. They are well integrated with our compute engine, with our distributed storage, and you can get the best scalability and performance benefit possible, since everything is well integrated. It's one system that works as a single unit, even though it's distributed. However, when we were talking about TensorFlow, not even TensorFlow, about deep learning, we decided that we don't want to implement deep learning algorithms out of the box. And the reason is simple. Speaking of machine learning, we see a major adoption of machine learning in general business, everywhere. Let it be finance, let it be e-commerce, retail, logistics, like everywhere. Machine learning algorithms are already widely used. However, I cannot say the same about deep learning. Deep learning is still lays in the focus of companies which are dealing with machine vision, with voice recognition, with something more advanced. And that's why there is still no any major adoption. And we decided not to reinvent the wheel and went ahead and integrated with TensorFlow. So what are the perks? What are the main things related to that integration? First of all, Ignite is represented as a distributed storage for the TensorFlow computations. So all of the data can sit in Ignite. And then you are using basic and standard TensorFlow APIs in Python or any other language which might be supported to code your machine learning, to code your deep learning models and tasks. And the data will be taken from your distributed Ignite cluster. What we also try to do here is to try to avoid as much as possible data movement from our Ignite nodes to TensorFlow nodes. And turns out to be that there is a way how we can minimize the ETL part between TensorFlow nodes and Ignite nodes. If you follow one simple deployment approach, if you deploy, let's say, a TensorFlow node along with an Ignite node on one of the physical machines, then that specific TensorFlow node will be working with the Ignite node, which is deployed in the same environment, in the same, let's say, physical machine, or in the same virtual machine. In this deployment configuration, there still will be data movement between the TensorFlow node and Ignite node, but that would be in-machine data movement. The data will not be moved over the network. It will be copied just using the local RAM, using the local memory resources. And that's one of the advantages, even though, yes, the data has to be ETL'd, but if you follow this approach, then the ETL part is minimal. So that's good. That's what already available, and that's something that you can already try and see whether you are getting scalability and performance benefits of having Ignite as a primary storage for your TensorFlow computations. Speaking of the roadmap, and I think that's something that we are considering, we might want to see, depending on your feedback, guys, because you are our users, you are those who can guide us, who can guide the community. If you see a lot of the value, if you see some of the gaps in this integration, then come to the community and share your use case and tell us what's missing or what should be considered for the roadmap. But what we are thinking of, and we will see how we can support the true TensorFlow tasks in place execution in Ignite. What does it mean? It means that, let's say, if you want to execute a TensorFlow task, you want to avoid the data movement at all between Ignite nodes and TensorFlow nodes. It's extremely hard to do that, but since it's a technical task, it's possible, and that's something that we're considering. So, but right now still, we are waiting for the first feedback. We are doing some of the obvious improvements, so try it out, use for your TensorFlow workloads, and come to us, share your feedback, and then we'll together can define the roadmap. So overall, as a summary, right, let me repeat this again. You as a TensorFlow user, nothing has changed for you. You use your lovely framework to code in your deep learning tasks. What has been changed, the data will be stored in Ignite, in a distributed storage that can handle not just gigabytes, but terabytes and even petabytes of data. With that special deployment approach, where each individual TensorFlow node is deployed along with an Ignite node, you can minimize your ETL costs. So the data will be moved, copied only over the local memory space over specific physical or virtual machine. And also the fault tolerance. You know that TensorFlow is fault tolerant, Ignite is fault tolerant, and whenever you're running your deep learning calculations, which can last for hours or days, if anything fails, it doesn't mean that you need to start from scratch. Both Ignite and TensorFlow will write down the state, and they will restart the calculation from their point of failure. All right, that was TensorFlow. You can try to run some of the examples. Google for our blog posts related to that TensorFlow integration, and try to experiment it and share your feedback. The next topic, multi-language support, thin clients. So first of all, let's talk about the thin clients. Those of you who are already using Ignite or GridGain, you know that there are three primary languages which are supported: Java, .NET, and C++. And the community releases kind of special libraries for those languages. But it was really hard, for instance, and it's hard to maintain, it's hard to develop those regular libraries when you're creating regular clients which are connecting to the topology, to the cluster, they become full-fledged members, etc. It just takes a lot of time. And then we were sitting and thinking, how can we, increase the adoption, how we can support every possible language without creating a regular library, a regular client for everything. And we came up with a simple approach. We created a so-called socket-level binary protocol, which allows you to connect from any programming language. You can even use, let's say, if you have any embedded device or smart meter, and you're using some ARM, or let's say that assembly or C++ native libraries which support basic TCP/IP connectivity. You can even connect from those devices to your cluster right now in the usage of that protocol. So the idea of the protocol is for sure, since the protocol is based on the straightforward socket on TCP/IP communication, you just need to open a connection to one of the servers in your distributed cluster, and then use your key value SQL or other APIs. And a thin client is an API, that lightweight API, which is implemented on top of that protocol. And we are following some guidelines. And for instance, speaking of the APIs, we support, let's say, key value SQL operations. And whenever we are deciding to provide support, let's say, for Python out of the box, then we just design that API. And when it came to the implementation, that API was implemented based on the socket level binary protocol. That's it. It's straightforward. It's simple. And starting with Ignite 2.7, below you can find a list of the languages for which we now supply thin clients. So we also supported thin clients for Java, .NET, and for C++, even though we had regular clients. And also right now we supported Node.js, Python, and PHP. So if any of you prefer to use Python, Node.js, or PHP, or you were thinking about this, but Ignite liked this functionality before, now the time has come. Try it out and use it. We already see that, let's say, languages like Node.js or like binaries for Node.js and Pythons are being downloaded a lot. So there is a demand. Hopefully those languages are useful for you as well. And at this slide, let me just compare. Let me just do a quick comparison. What's the primary difference between regular and client and thin client? And I just chose 4 main criteria. The first one is cluster communication. Speaking of the regular client, that's a full-fledged client. It's not a heavyweight, but it starts a JVM process internally so that it's able to connect to the cluster. It means that even if you use regular .NET or C++ client, inside of your .NET or C++ application, we will start the JVM process, and that JVM process will connect to the cluster and will forward a lot of the queries and different commands which you are running. And also this requires to have many ports opened for your client applications. Speaking of the thin client, it's much more lightweight, right? As I said, you're connecting to one of the servers in your cluster, or you're supplying a list of the servers, and then the thin client will pick one of the servers, will connect to it, and that server will be used as a proxy for all of their operations. And that's good. Like, for instance, now if you're a .NET or C++ user, you're just connecting through the thin client to your cluster, and you're not starting any JVM process internally. But also there are always trade-offs, at least right now. The first trade-off is scalability and performance. You can expect to get the best scalability and performance benefits out of the regular clients, because that client is a member of your cluster topology. And whenever you are, let's say, running any key value operations or any affinity computations, that client internally will go to a primary node. It will not be working through a proxy node. And your cluster will be load balanced, because that client node, that client application will always be going to the node which hold primary copies of the data needed for the requests. That's something that is not supported yet for the thin client. Right now, as long as the client communicates through the proxy, that proxy will be getting all of the requests from your application, and then that proxy server will redirect the queries to the primary nodes, for instance. And also that server proxy will be used as an intermediate storage for your results, which are being sent from one of the nodes to your client application. But right now, for Ignite 2.8, we are working on the partition awareness, which will allow the thin clients to know how the data is distributed, who is the primary node and who is not, and the thin clients will be able to connect to the primary nodes directly from your application. So the communication through the proxy server will be minimized. So that's the difference in terms of scalability and performance. Supported APIs, regular clients, everything you have in Ignite. Let it be SQL, key value, machine learning, deep learning, compute, service grid, everything. As for the thin client, there is a subset. Right now we support get and put SQL. You can do some configuration changes. Also, we are thinking to provide limited support for compute grid, and also we will support transactions. But that's how it works right now. So trade-off, pick and decide. And as for the languages, as for the regular clients, Java, .NET, and C++ have been supported historically. But as for the thin client, you can support any language easily. You don't even need to wait for the community. If you have Golang or you have any native C++ library or native C++ compiler, and you want to connect your edge devices, your smart meters, straight to the cluster, you can code it. You can use our thin clients, or you can use our socket level protocol. So let me quickly show you a simple example. Let's take a pause and see how the thin clients work in reality. All right, so here is I have let me make the font size bigger. Let me start a couple of Ignite server nodes. All right, the first one is started. That's Ignite 2.7, right? Yeah, the latest version. We are starting the second node. All right, join the cluster guy. All right, it's here. And now, if you download Ignite 2.7 release, here is you can find Node.js examples. So I decided to showcase Node.js today, but also you can do the same for Python or PHP. So for instance, here is in the examples folder, we have some of the most straightforward examples, like cache get put example. So what we do here, we are defining some of the essential objects, Node.js objects. We are creating Ignite client, endpoint. I know that my cluster is running on my local laptop. I am predefining some of the objects, and then where is my main routine? Here is my constructor, right? We can skip the top of the example. Here is I'm creating Ignite client connection. That's the API. We are connecting to it, to my endpoint. Then we are creating an object, person, which I want to put in a cache. And that's my cache. And I decided that a cache can be pre-created if you define it in your server-side configuration. But here is we decided to show how you can also configure or start caches dynamically in runtime. Here is I'm starting my cache. And then I'm using put method to put some objects into my cache using Node.js API. And after that, I'm doing a reverse operation when I'm trying to get my objects from the cache. So here is my cache object. I'm getting the value, I'm deserializing it, I'm just doing some comparisons, and I'm writing the output to the log files. So how we can run this example, right? So you can, first of all, just follow the standard documentation, get a started guide created for the Node.js. But I decided that with Node.js, I don't need to, I can use my command line interface to run this example. So that was the example which we checked right now. And now let me just execute it using npm command. Oops, mistake. Node, yes, sorry. npm is for the installation, sure. Apologize. All right. And you can see that the client connected to the cluster, it created some of the objects. We could execute put all, we put the data, we get the data. So when we are it connected to this cluster. Here, as you can see, and that's what's different between the regular clients and the thin clients, the topology snapshot did not change. So here is, you can see 0 clients. It means that if the number is not 0, it means that someone has connected as a regular client. But here is we are connecting as a lightweight client using socket connection. That's it, pretty simple. And just in the background, check the rest of their APIs. Or also what I have here, we can try to run SQL example, right? It's SQL example. It also will connect to the same cluster. Created and executed some of the SQL queries. So the source code again, the source code is here. Let me use the IDE to check it. Again, we are connecting, but then we are using SQL language to query the data. Straightforward. Just the only difference is that right now this is officially supported for Node.js, Python, and PHP. All right, let's move on. So the next topic would be transparent data encryption. Speaking of the transparent data encryption, why we decided to add it to Ignite. So the primary reason is that with all of those hardened regulations, for instance, I think that many of us heard about GDPR policies, which were applied in Europe, and policies like those are being reviewed and also being applied in other countries. All that means that now the storages, especially those storages which are working with our personal data or sensitive information, have to be sure that this information will not leak if your system is hacked or if your system, if someone else gets access to your system. And this ability also now available for Ignite deployments. So first of all, what do we encrypt? We encrypt data which is stored on disk. It's related to the partition files, to the and also to the write-ahead log files. So the reason is that if anybody, it's hard to hack RAM, right? And that's why by default we do not encrypt anything in memory, especially because it can diminish your performance scalabilities. But when it comes to disk, if someone gets access to a system, if someone gets access to disk drives, yes, the data has to be encrypted. And you can decide, right, what you'd like to encrypt. The encryption can be enabled and configured per cache label. For each cache, we'll create a special encryption key. By default, this encryption key will be stored in memory in a special system cache, which is inaccessible from the user space. I mean, it's inaccessible from your applications. Only Ignite, special Ignite system threads can get access to it. But also we know that Ignite nodes are being restudied, and sometimes we need to bring down the entire cluster because of some of the maintenance tasks. And the encryption keys will be persisted to disk. And whenever we persist our encryption keys, or we need to transfer them from one node to another, then we have to use a so-called master key. And that master key can be generated by a third-party enterprise tool if you have. We know that many companies, yes, they use transparent data encryption, but the master keys are always stored in a separate system. The idea is pretty simple. Let's say that your system was hacked. Someone got access to your disk drives, and now he has all of the data. But nobody will be able to decrypt this data if the master key is missing. And the master key can be stored in an enterprise level solution, some service. But out of the box, we decided not to complicate the things, and out of the box, we created a special expandable interface so that you can integrate with any third-party tools for the master keys management. And out of the box, we are storing the master keys in the GDK store. of the virtual machine, so that you can use it for the development, you can test it, you can try it. If you find you can use it for production, but if you're in your company, there is a rule to use something different, then you can do that. Just expand the interface, provide a specific implementation needed for your use case. And let me just show you where you can find an example. So in Ignite 2.7, we have a straightforward example that showcases how to use this functionality. So here is we are going to connect to the cluster, and I would stop these two nodes right now because they are started with a different cluster configuration, so they know nothing about any encryption capabilities. But this example, it will be using this different configuration. Let me show it to you. And here is, yes, we are enabling our persistence. First of all, we have to enable persistence. The data will be encrypted on the persistence level. And here is we're defining our encryption related settings, like key store path, password, master key, and some other various parameters. Once this cluster is started, we will create this cache, which stores, let's say, your bank account. And we want to encrypt all the information related to the bank account. And that's why we are setting set encryption enabled value to true for this cache. Then we are creating this cache. We are adding some of the bank accounts to it. And after that, we will stop our cluster. And we will restart the same cluster. We will activate it. The data will be encrypted to disk, and then we will try to read all the data back, and we will try to print it out. So on the disk, it will be encrypted, but whenever you're trying to get it back and read it on your application side, it will be decrypted automatically. So let's start this simple application. Okay. Okay, security status, encryption keys are loaded. So yeah. Cache with the same name already started encrypted cache. I think that, yes, I was playing with this demo and the cache was already created. So what we need to do, I can go ahead and clean a special directory in my work folder, because by default all of the data is persisted to this DB folder, and that should be my node. Let me just clean all of the details from here. Or you can just update this example, and instead of creating the cache, you can use get-to-create-cache method. But I want to show how this example works if you start it for the first time. Okay. So let's check the logs. So we created an encrypted cache, added some data into it, our bank accounts, and then we restarted the node, and we read all of the data back. So the data was decrypted on the application side. And here is, but when it comes to the persistence, right, the data, all of the data sits in these files, like partition files. And within those partition files, the data is encrypted using their cache keys and the master keys. So that's it. Let's move on. And the final section of our today conversation would be SQL, transactional SQL. So in general, while we're waiting for the presentation slide, SQL, even though historically Ignite was used as a key value storage, and it has advanced key value APIs, compute APIs, and now we see a growing and tremendously growing number of SQL deployments. Whenever I'm having any conversations with users or Ignite users or GridGain customers, SQL is almost everywhere. That's because the primary reason is because even for simple use cases, sometimes you need to have advanced queries which can filter the data, or for instance, some of the queries which can return you the data based on the time of the day or based on some geographical location, some other parameters, and key value APIs are not good for that. Key value APIs are good for quick and primary key-based lookups. And many cache in memory data grids or distributed cache solutions, they provided their own APIs for advanced querying. But we decided not to reinvent the wheel. We decided just to support SQL, and that's why now whenever someone uses Ignite and needs to use any advanced querying capabilities, that person will be using SQL. And also we are seeing a lot of SQL-specific deployments when the SQL is the primary API for data access. However, you also know that Ignite supports transactions. And whenever you wanted to use transactions in Ignite, you had to fall back to key value APIs. And that worked, and that works for a while. Key value APIs support distributed transactions. They are battle tested, they are deployed, as I said before, at many financial institutions, including well-known banks. However, SQL gap was pretty impactful, and that's why our community has already spent more than 2 years working on the transactional SQL. And right now, in the end of the year in Ignite 2.7, we achieved a huge milestone. We released the beta version of this API. So right now, what it means, you can start Ignite cluster, you can create special caches with the atomicity mode equal to transactional snapshot, and then you can start Ignite distributed transaction, and you can use selects, inserts, updates, and deletes. Everything is based on multi-version concurrency protocol, and we support snapshot isolation for that. All of the consistency is guaranteed because all of those transactions are managed by a coordinator. The coordinator is one of the nodes which will be elected to fulfill this role. But for sure, like throughout the cluster lifetime, the coordinator can be re-elected, can be changed if the nodes, like if the cluster topology changes. So basically, if you look to the right, now you can do all of those simple operations. The example to the right is for those who are using JDBC or ODBC drivers. You can just connect, let's say, and execute insert, update, select, etc. Everything will be transactional. From the Ignite Java APIs, you can do the same, but using Ignite APIs. Speaking of the limitations, just check this reference, which you see on the slide. For instance, there are some of the gaps related to the events handling or to continuous queries, but they're minor. And right now, the community has been working on their advanced stability and performance optimizations of this component. Once we are confident that all of the major performance and scalability and stability questions are addressed, we will roll out the J release. So our internal goal is to accomplish this year for sure, and as soon as possible. And absolutely try this functionality and share the feedback with us. It's still in beta, but we anyway want to get the first early adopters, and we want to see how you like this, what should be changed, or what doesn't work the way we expected it should have worked. All right, and then the final example before we finish our conversation. I want to show you how to run the transactions. So let me restart these two nodes. I decided again to use my command line interface to demonstrate how to execute distributed transactions. So with Ignite, we are supplying SQL line tool. See it as your command line tool for SQL in Ignite. So I'm connecting to my local cluster. All right, I'm connected to the cluster. And also I prepared what I did. I went ahead and updated the existing configuration, yeah, the existing example configuration. So here is with Ignite. In examples, you can find this Vault SQL script, which you can use, to preload some data in your cluster and experiment with it. And here is the only one thing which has changed is this. I changed the atomicity mode to transactional snapshot. Now, once those tables, SQL tables and underlying caches are created, I will be able to run SQL selects and sorts updates for them within transactional boundaries. That's the only change which I did. So now let me preload this. Here is the command. It was cached. Yeah, I am running the script. Okay, the data is preloaded. Okay, all of the tables are created. And let me use my cheat sheet. So yes or no, I don't have it. Then we will do it this way. So let's select some of the cities. So I selected some of the cities like this one. That's Vicenza, and the population is more than 100,000. And also there is another city like Teman, and the population is the following, also around 107,000. So now what I want to do, I want to update the population of those two cities using transactions. So here is I have somewhere update the city. So we decided that some of the people, around 300 people, move from one city to another. So what we are doing, we are updating the first city, the population, decreasing the population. And then for the second city, we are increasing it. So we just need to add. And now we need to commit the changes. All right. And finally, that's what the transaction, right? The simplest approach. And that's how it works with Ignite. And now if you re-execute the same queries, you can see that the population has been changed for both cities. So here is we removed some people, and here is we added some of them. Pretty simple. That's it. Okay, and before we jump to the questions section, let me share a slide with some of the useful resources with you so that you can go ahead and find more details about discussed features. So just everything is explained on Apache Ignite README documentation. So TensorFlow, thin clients, transparent data encryption, or transactional SQL. Also, we didn't touch a lot of other improvements today. So if you're curious about what else was released in Ignite 2.7, just go to and check our release notes. Pretty simple. And finally, for those of you who are Apache Ignite users, I'm also excited to announce, and that's like a minute of advertisement. You know that GridGain is one of their major contributors to Ignite, right? And at the same time, we value Ignite community and we are dedicated to the contribution to the community. At the same time, we see that many Ignite users, sometimes they need to have quicker responses. They want to have their problems solved quicker. Yes, we have the community channels. We GridGain employees also take part in those conversations. But I was in the role of a developer, or like I was sitting on the other side of the bench, and I know that sometimes it's critical to get a response or to get a solution for my needs as soon as possible. And that's why GridGain right now offers to Apache Ignite users so-called basic support. if you want to have an initial 2 hours conversation with our expert, and that expert can check your architecture, it can give you some recommendations or do some suggestions and corrections. That's available in this package. And at the same time, it will provide you 9x5 global support for your deployments over web and email. We will help you to identify bugs and file them for you in the Apache Ignite community. We will not be fixing them, but we can try to prioritize them for you. But anyway, so if we detect any issue, any bug, we will be able to supply a workaround. And also it includes performance considerations, scalability considerations, etc., etc. So if you're interested in this, then check it out. So that's it from my side for today, and I'll be happy to answer your questions.
All right, so we have a few. I try to save the hardest ones, like I said. There was one question about thin versus regular client. It really, if I could paraphrase, what's the difference and what's the similarity between thin and regular clients, and where should I use each one?
I think that I've answered this question when we were, let me show that slide. You can just download it and check it. So basically, those are the primary 4 criteria you can pick. But if to summarize, the thin client is more lightweight. And whenever you're joining through a thin client, you are not started any JVM process internally. And that's pretty, that was a big deal for some of the .NET or C++ regular clients. When, for instance, if we are talking about .NET or C++ regular client, then we are starting a JVM process inside of your .NET application or C++ application. That was a big deal. But at the same time, speaking of their scalability performance, the thin clients are not aware of data distribution. That's why all of the communication presently go through a proxy, through the server nodes to which the client has connected before. But that's something that will be addressed soon. And what's left is that the regular clients provide all of the APIs available in Ignite or GridGain, while thin clients, they have a limited support. So for your use case, let's say that if you are fine to walk through a proxy server, through the proxy node, and you and get or key value and SQL queries are more than enough for you, then the thin client is what you need. The regular client is for the rest of the use cases.
Yeah, it's physically a different protocol and a different port. And I guess with Kubernetes, with Docker Kubernetes, especially with Kubernetes, it's easier to actually connect with a thin client than it is a thick client, a regular client, right?
Yeah, correct, and that's especially true if, let's say, you have a so-called heterogeneous deployment, when something is deployed in Kubernetes and something is outside. And if your applications are deployed outside of Kubernetes, but you have to access the Kubernetes environment, then the thin client is what you need.
Yeah, so I think it's just a good warning for people. If you're setting up Kubernetes and looking at it, the ingress, accessing a Kubernetes cluster, it was kind of designed for more web-based apps and accessing via HTTP or maybe TCP/IP. So it's not. There's some things that kind of take you by surprise if you're used to building an app that you're not accessing it that way. It doesn't actually work as easily. You have network issues. So just be aware of that. And if Kubernetes is one of your technologies you're using, you need to think seriously about using the thin client versus the regular client. There was an acronym CLF. I missed it. I apologize. I thought maybe it was Common Language Framework, but I did not know for sure, so I thought I'd ask. You said CLF at some point. Do you remember earlier on?
I don't know. What does it stand for?
Yeah, so maybe it was Common Language Framework. That'll be my final answer.
Continuous Learning Framework.
Yeah. So another question I got, and we've gotten this a few times, to the point where we even have it in some of Akmal's blogs. How do you split up data for training versus actual usage model, model training versus testing, and manage it? What are your recommendations? And I did send on some links to the blogs. And for those of you who are listening, Akmal blogs regularly on these types of topics. He has a series of blogs on machine and deep learning, starting with TensorFlow, the genetic algorithm as well. And he uses some tools for splitting up data. I'm wondering what you would recommend for managing data and how it's actually managed inside Ignite. Your training data versus your testing data, for example.
Yeah, like once, for instance, speaking of the initial data split, right? When you have this other data set and you want to pre-process this data and split it into a training set and production set. There are some of the tools, and also now with Ignite 2.7 we definitely support some of the pre-processing APIs. So just go to the Ignite documentation and you'll find a pre-processing section, and we developed some of the examples. And once you split your data into those two sets, it's like then you would do what you would do with other languages. You would preload, let's say, you can preload your training set into your GridGain or Ignite cluster, and then execute some of the training routines. And whenever you are thinking that the model is good, create your, let's say, production caches, tables, which will hold your production set, and assess your model. I think that I was checking our existing examples, and I think that we have those concepts explained in the examples, which are available with every Ignite distribution. But anyway, if you think that something is missing, don't hesitate to send message to Ignite user list or dev list. We have Ignite ML and deep learning committers sitting and watching the list.
Yep. Okay, great. Final question. Can Ignite use BitLocker? What other, or put another way, what different types of disk encryption can be used with Ignite? And how does that relate to the transparent data encryption?
As I said, like out of the box, we support some standard algorithms which are implemented by GDK, and we use GDK store to keep our master keys. But I want to highlight it once again. Ignite was always designed as a pluggable or extendable project, and the same applies for the transparent data encryption. So basically, if you have a other third-party security system or algorithm which you would like to use for your data encryption, then just implement your version of their pluggable interface, and you will be able to use it together with your Ignite cluster.
Okay, so you can implement you can basically implement the plugin.
Right. Also, like if just to refer to my latest slide related to Ignite basic support, if you just unsure that it's possible, you don't have enough knowledge, etc., just talk to our experts.
Okay.
The GridGain experts.
Okay. Sounds good. I just remembered on the machine learning on the data, creating the training data. I guess we were using Skigit-learn, right? But that we've been talking about adding some tooling into Ignite for splitting, but that's on the roadmap for a future release. Is that correct?
We need to check like the pre-processing. Pre-processing, in my understanding, also includes splitting phase. So
right.
just check what's already we were receiving that feedback related to the pre-processing APIs, and we supported some of them in 2.7.
Yeah. So for those of you who've looked at the different types of machine learning algorithms, there is a category called pre-processing where you can actually pre-process the data, prep it before you actually run an algorithm, and that's what Dennis is talking about. All right. Well, Dennis, thank you so much. If you have any questions, feel free to reach out to the Ignite user list. You can also reach us at GridGain. You can try to contact us. My email is rob.meyer. Dennis, are you Dennis or D Magda? I think you're D Magda. But feel free to reach out anytime, and we'll do our best to answer questions. Remember, if you have a question, many other people too do as well. So it might actually end up being another webinar topic. So with that, enjoy your coding, and I guess we will hopefully see you soon on the next webinar.
Yeah, thanks.